Hello, so we have another intersection problem. So we have a quadratic equation y equals to x minus 1 whole square, and that's essentially that's interfering with a straight line y equals to x minus x plus 3, 4x plus 3, y is equals to 4x plus 3. We have been asked to calculate the points of intersection of this problem of this parabola. So we have essentially y is equals to x squared, which is looking like that, which y is equals to x squared is the parabola passing through the origin. So y is equals to x minus 1 whole square is the parabola, is the same parabola moved towards the right shifted parabola by a unit length. Okay, by a unit length. So that's the parabola which we are concerning ourselves with. So right, so that's essentially this point is 1 comma 0, because it has been moved to the right side of the x-axis by a unit of 1 without changing the y-axis. So we then have a line which is y is equals to 4x plus 3. Therefore, the y-intercept is 3, and the gradient of this equation is 4. Pretty steep gradient. Okay, so y is 1, so it meets y is 3, and that's the equation of this line. Okay, so it meets 1 here, but it could also meet on the other side. Let's try and find out where does it exactly meet. So we are trying to find points A and points B. Okay, now we first simplify this equation. So what we have here is y is equals to x minus 1 whole square, which is quite simple, x squared minus 2x plus 1, and we also have y is equals to 4x plus 3. Let's choose a substitution method. They both are same, isn't it? And y is equals to this, and y is the left hand side of both the equations are same, therefore the right hand side of the both the equations must also be the same. So you have x squared minus 2x plus 1 is equals to 4x plus 3, right? So then this is going to be pretty simple. So x squared minus 6x plus 1 minus 3, which is minus 2, is equals to 0. Let's try and calculate its values. Do we even have a point of intersection here? It appears so. Let's try and calculate what is that exact point of intersection. Okay, so how do we do this? So we consider the quadratic formula, which is ax squared plus bx plus c is equals to 0, and a is 1 here for us, and b is minus 6, and c is minus 2. So the roots of this equation are minus b plus or minus b squared minus 4ac divided by 2a. So this is minus b is going to be plus 6 plus or minus b squared is going to be 36. Very good. Minus 4 times 4 times 1 times minus 2. Okay, everything divided by 2 times a1, which is 2. So that is 6 plus or minus square root of 36 and plus 8. Okay, so this is divided by 2. So what do we get from this? We're going to get 6 plus or minus 44, isn't it? So 44 is 4 times 11, that is square root of 4 times 11 divided by 2. So that is 6 times 6 plus or minus square root of 4 times square root of 11, everything divided by 2. So that is 6 plus or minus 2 square root of 11 by 2. So 2 is a common factor, so I can take that out. So that is 3 plus or minus square root of 11. So that means I have two solutions. One is 3 plus root 11, and the other one is 3 minus root 11. So what I didn't do is I find out the corresponding points or the values of y-axis. Okay, so the easier equation amongst these two is equation for the straight line. So I'll substitute the values of x into both of them. So then when I put that into both of them, what I'm going to get the values of y. So which is, for this value is going to be 4x plus 3, 4 times 3 plus root 11 plus 3, and this is going to be 4 times 3 minus root 11 plus 3. So this is going to give me, what is this going to give me? This is then going to be 12 plus 3 is going to be 15 plus you have 4 and root 11. So this is going to be 3, 12 plus 3. Okay, again 15 minus 4 root 11. So the points of intersection that we have are one is let's have a look. This is right. Okay. Right. Okay. So 3 plus root 11 comma 15 plus 4 root 11, and that's the first point of intersection. And the second point of intersection is 3 minus root 11 and the corresponding value of y, which was 5 minus 4 root 11. So if we do plot them up, what are we going to get? We are going to get these points, which is point A here. So let me call that as point, that is A and that is B. Okay, so how do I identify that these are A and B? So obviously this is a negative value, so it got to be on the negative side. So that's a positive value that got to be on the positive side. Therefore our corresponding values of y are also correct. So this is lesser than this, so that means this has to be point A and this has to be point B. So now how did I move from here? So this is 3 plus 1 over there here, and the corresponding value was, if I move along this line, so I get 15 plus 4 root 5, so we get 15 plus 4 root 11. And similar case is with this case here. I move here and I move here and I get that number, and that number is the same as this one. So the problem is solved. So there are 2 points of intersection A and B, and these are the point coordinates. Okay, there are some more questions like this. Do not forget to solve them up. Do share this course amongst your friends and leave some good comments, and also do not forget to like and share this course with the general public as well. And I'm going to be coming up with more great content like this that's going to be helpful for lots of students in understanding, strategizing and solving and accurately representing their solutions and so on and so forth. I'll see you in the next video. Okay, take care.